Hello everybody. Today we're going to talk about implementing Cisco Enterprise Wireless Networks, or as it called Cisco 300-430 exam review. But before that, I'm going to talk about 591 Lab. It is the top IT training and certification exam brand in China, Hong Kong, Taiwan, Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications such as Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we're going to talk about implementing Cisco Enterprise Wireless Networks. And in today's video, we're going to talk about hyperlocation and how it can be implemented along with the wireless LAN controller, prime infrastructure reports, CMX, and MSE in order to accurately point out locations of any clients or rogue devices on any client that are connected to the controller, or any rogue devices that is trying to interfere with our networks. And also we're going to talk about security and security methods for client connectivity such as .1x. All right, let's get right into it. Refer to the exhibit. The image shows a packet capture that was taken at the CLI of the Cisco CMX server. It shows UDP traffic from the WLC coming into the server. What does the capture prove? So basically we have capture taken at the CMX side. It shows traffic from the WLC. So basically we can understand that the source here we have the the IP that ends with 251 is the controller IP, and .21 is the CMX server IP. We can see that it's a UDP packet. It's the source of the port is 49s, and it goes into the 2003 port at the CMX. So we need to understand which packet this is. Let's see what options do we have. The CMX server receives net flow data from the WLC. So what we need to understand is which one of these have the correct either 2003 or 49's port. So let's check them one by one. Net flows basically uses UDP port 2055. So this is not our correct one. NMSP uses 16113 TCP port, so it's not the one that we're looking for. SNMP uses basically two ports, 161 and port 162. And again, this is not the port that we're looking for. We have another option here as angle of arrival, or AOA, data from the WLC. So this one uses 2003. The AP itself encapsulates the AOA packet inside a CAPWAP into the WLC. Therefore, 2003 has to be open between the WLC and the CMX, and then the WLC uses the 49's source port to send it into CMX, and the CMX will receive it at this port. So the correct answer for this is D, angle of arrival. Next one. An engineer must restrict some subnets to have access to the WLC. When the CPU ACL function is enabled, no ACLs in the drop-down list are seen. What is the cause of the problem? So the engineer basically want to enable the CPU ACL and check here the box, but he cannot see any ACL names under the ACL name here. What is the cause of the problem? Okay, let's check the options. When the ACL is created, it must be specified that is as CPU ACL. This is not correct, as any ACL can be used, either a normal ACL or a CPU ACL. No ACL has been created under the access control list tab. This could be interesting because if there is no ACL that been created, it's gonna show us as none. So let's keep this in mind. The configuration must be performed through the CLI and not through the web GUI. This is not correct. As you can see, we can, in matter of fact, have a GUI access or options to enable ACL and to specify the access lists. So this is not correct. The ACL does not have a rule that's specified to the management interface. Basically, CPU ACL is a dynamic interface. We can apply it to multiple interfaces. So this one is not correct as well. the one that is correct indeed is B, no ACL has been created, because if there is no ACL under access control list, it's going to show us as none. So the answer is B. Then we have this question. It's a match one. A wireless engineer wants to schedule a monthly security reports in Cisco Prime infrastructure. Drag and drop the report from the left into the expected results when the report is generated into the right one. Basically, this is an easy one because every report has a name, whether to adaptive web summary or rogue count summary. It's gonna be it's self-explanatory. So an adaptive web's alarm summary is basically gonna display a summary of all adaptive web's alarms on the network. So this is the option we're looking for. Ad hoc rogue count summary. Here we have two actually options. We have the ad hoc rogue count and we have the rogue AP count. This one will only have a summary of the ad hoc rogue count, and this one will have a summary of the rogue AP count. So we have to be specific with this. It's going to only show us the ad hoc count of all the ad hoc rogue access points. So this will go here. And the rogue AP count, it will show us the count of all rogue access points on the network. So this one will go here. And the last one is a security alarm trending. It's going to show us or display an alarm of security trend over a period of time. So this one goes right here. Pretty easy one. Next one. A wireless engineer has performed a Wireshark capture on an .1x authentication process to troubleshoot a connectivity issue. Which two types of packets does the EP contain? Choose two. So in order to understand this, what type of packet it's gonna be, we need to understand the handshake that the EP has. So the client here we have the client, the device, or it could be the controller or the switch that we have, and the authentication server that's gonna do the authentication. So here we have the client starting the EP by sending EPOL start. The device is gonna send an EPOL request, EPOL response, and then the authentication server will do its part by requesting and responding with challenges, and then either we get an EP success or more challenges, and then either a log off or a failure in case of a failure. Here we might think that we are looking for an EP failure, but if we want to troubleshoot a connectivity issue, we're going to have to look before the EP failure. So of course, when we have a failure, it's going to be an EP failure, no question about it. But we don't look into that packet. We look previous to that packet, what happened before that. So someone might answer that the answer is EP failure, but that's not the correct answer, as we need to look into what happened before that. So if we do not get an EP success, basically the device is gonna send us an EP request requesting for more identity or more question or more challenges. So one of the things that we need to check is the EP request. What did the device exactly send, or what the authentication server asked for? And also we're looking after that, the EP response. What did the client respond? Did it respond with the wrong credentials or something like that? So the answer is going to be, we're looking into the EP request and EP response. So it's going to be these two. Next one. A network engineer must configure APs on a controller for .1x access to a wired infrastructure as quickly as possible. The same credentials are used for all APs where the credentials entered. Okay, so basically we have APs that we need to authenticate using .1x into a wired infrastructure. So basically we have a switch that we need to authenticate the AP based on. But we have many APs that they're using the same credentials, and we do not want to enter each AP to do. So if we look into this option here, AP credentials tab, this can work, but we need to go into each AP and enter the same credentials. So it's going to be really tiring and really waste of time. So this is not an option. The second option is security advanced EAP. This option is for clients and not for the access points. So definitely it's gonna be not gonna be that. The last one here is management, local management users. So as it says, management users, this will check the security of the management users and not the access points. So definitely we're not gonna need the management tab here. What we need to go into is the wireless tab here, and then global configuration. Then we can enter the supplicant credentials, username and password, and confirm password here, and then click apply. This will apply to all of the access point at once, so we don't have to go to each access point and enter the credentials. So the answer is going to be wireless tab and then global configuration. Another question that we have is, you are configuring a social login for a guest network. Which three options are configurable social connectors in Cisco CMX Visitor Connect? Now, a social login is when you have to use other social platforms such as Facebook or Google or something else as a login page instead of putting a password or something like else, something that you might do in an airport or a hotel. So instead of show you or redirect you to a login page, you end up with a third-party page where you, for example, log in using your Facebook credentials instead of another password or something else. So basically, to answer that question, we need to know what Cisco CMX basically support of these sites. And if you go to the CMX page or support page, you can see that a note that says you can use Facebook, Google+, and LinkedIn sites to create social connectors. The visitors can use credentials for any of one of these connectors. So basically, when you log in to your guest SSID, you can basically use your Facebook credentials, Google+, and LinkedIn in order to log in and get Wi-Fi access. So the answer is basically Facebook, Google+, and LinkedIn, currently supported by the CMX Visitor Connect. Next one. A network engineer is configuring a Cisco AROS 8.2 WLC, Cisco MSE, and Cisco Prime infrastructure with Cisco 3700 series APs and Cisco hyperlocation modules. The engineer configures and enables a wireless LAN with hyperlocation during testing. The engineer notices that the location accuracy is poor. Which action resolved the issue? So basically, the way we look at this is you check whether in the first place, are we getting the locations or not? Because if we're not getting them, then there is something in the configuration is wrong. The compatibility between the three platforms is not, or three devices is not supported or something. But in our case, we are getting actually some locations. However, the accuracy is poor. This is very important when it comes to troubleshooting. We need to know, is our setup is even working or not? And then if we are getting less accuracy, then we need to tweak a couple of things in order to make it work better. So in order to answer these, we need to understand the minimum requirement for hyperlocation. And if we go to Cisco website for CMX and hyperlocation, we can see that the minimum hardware requirement for hyperlocation is basically to have a suitable Cisco controller, such as 2500, 5500, or anything else running 8.1 minimum. So basically, we know that we are running this requirement because we are running already 8.2. So on our software, it is 100%, so should be supported. Also, it should have AP3600 or AP700 with hyperlocation module. So since we're already using 3700, we know that the hardware or the access point in this case is supported by our by the hyperlocation. Wireless clients, we already know that we are getting some, we can see that we can see locations for some of the clients. However, their location is not very accurate. So if we look at the options that we have, install WLC software that supports the hyperlocation module, this is not our issue because we know, like I said, we already running the minimum required software. And if we look into the third option, option C, open SNMP port 161 and NMSP port 16113 on the controller. Now, like I said before, if we have connectivity issue or the hyperlocation is not working in the beginning, then we're gonna have to look into the ports because we should get traffic or packets coming into those ports in order to get hyperlocation information. But in our situation, we are getting some information, so we definitely know that these ports are open. It's not the issue that the ports are open because we are getting the information, but not very accurate. So if we did not get any information, hyperlocation information, then we know that it could be some ports that are not open. The fourth option is basically very far-fetched because dynamic channel assignment, okay, dynamic channel is definitely going to help us with interference or co-channel interference in order to not to have very co-channels interference in our network. So it's gonna help us, but definitely not on the hyperlocation. It's not related whatsoever in the hyperlocation. Of course, it is 100% recommended to enable DCA in any network, but it does not have any effect on the hyperlocation, at least not directly. So this option is far-fetched. Now, if you open Cisco hyperlocation, poor location accuracy troubleshooting on the Cisco platform, you're gonna see basically these two options that mentions very important points when you get a poor location, when you enable hyperlocation. One of them is ensuring that NTP server is up and running and ensuring that the same NTP server, this is the time server, is used for syncing time for three platforms, the WLC, the MSE, and the Prime. And this makes totally sense. If we are getting different timestamps on each device, definitely we're going to get some different locations. Even if it's by seconds, the controller, MSE, and the Prime is different by seconds, it's going to very much affect our accuracy, our location accuracy. It's not going to show us that we are 100% synced up. So basically, we need to use the exact same NTP server on all the platform or all the devices that we have. So the correct answer for this is basically using the same NTP server for syncing the time on the WLC, MSE, and the Prime infrastructure. The answer is B. Okay, thank you everybody for attending today's class at 591 Lab. We hope you find the material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you all in our future classes. Have a great day.